Hi everyone, today we will discuss about the Quine-McCluskey minimization technique. It is an algorithm which is identical to the K-map. What we are doing in the K-map, simplifying the particular Boolean expression. The same thing we are doing in the Quine-McCluskey also. But what is the difference here? Here we are using the tabular method and it is efficient to the computer algorithms. We are doing here the number of ones and alternate changes in the each and every bit. We will discuss upon that algorithm, and Quine-McCluskey usually used for the computer algorithm. Let's try with the one example how we can do the technique to minimize the Boolean expression using Quine-McCluskey method. First we will take one example. D is equal to f ABCD is equal to summation of 0, 1, 2, 3, 6, 7, 8, 9, 14, 15. In this we have 4 variable 0 to 15. So step 1, we have to arrange such a way that all the minterm listing upon the number of ones present in the binary representation. If it is 0, it is no one present in this binary representation. If it is 15, it contains 4 number of 1 in the binary representation. That we have to group it number of ones in a different group. Let's try with the example. For step 1, we will create one table. In that we can represent different grouping. So first we can make grouping, and that grouping is named as either 0 number of ones, 1 number of ones, 2 number of ones, or 3 number of ones, or 4 number of ones. So in this grouping, according to that, we will represent what are the minterms come to this, and then minterm we are represented as a m, and that minterm will represent binary representation. Binary representation here 3 bit, so it is B3, B2 and B1 and B0. We can represent like this. First example we will take for here 0. 0 means it is a minterm containing binary representation of 0 ones. So we will take m is a 0 and it is binary representation is all zeros. And we are going with the 1. 1 containing binary representation is number of 1 is 1. So we will go with m1 is 1 here, and number of 1 present here 0, 0, 0, 1. If you go with the 2, next one, 2 is actually containing 1 number of ones. So write here only, and it is 0, 0, 1, 0 representation. Then we will go with 3. 3 actually contains 0, 0, 1, 1. So it is number of ones is 2. So it will go to here 3, and its representation is 0, 0, 1, 1. So next go to the 6. 6 is again it is 0, 1, 1, 0. So it is number of 1 is 2 present. So we will go with the group of 2. 0, 1, 1, 0. Again try for the 7. Usually 7 means it is 0, 1, 1, 1. So number of 1 present is 3. So go for the 3 grouping. 7 here 0, 1, 1, 1. Again next go for the 8 one. 8 is actually 1, 0, 0, 0. So number of 1 is only 1. So go here and write 8. So it is 1, 0, 0, 0. So it has 4 part, only 1 present here. Next number is 9. 9 means it is 1, 0, 0, 1. So number of 1 present is 2. So go here and write 9. 1, 0, 0, 1. Then go for the 14. 14 means it is 1, 1, 1, 0. So it is number of 1 is 3. So go to number of 1, 3 group 14. It is 1, 1, 1, 0. And last number is 15. 15 can be represented with all number of ones. So it is group of 4. So 15 is 1, 1, 1, 1. So like this we are making the grouping. So table 1, listen carefully. It is step 1 what we are done. We are done grouping of number of ones present in the minterms. So either number of 1 present in zeros, number of 1 present in 1, number of 1 present in 2, number of 1 present 3, number of 1 present 4. total 10 number given here. In this 10 number of 0 present is only 1, that is 0. Number of 1 present is 1 to 8 in binary. See, 1 is present in B0 and 2 is present in B1, and in 8 1 is present in B3. Similar way, 3, 6, 9 containing 2 ones, and 7, 14 contain 3 ones, and 15 contain 4 ones. Next, move on the step 2. In step 2, we have to make group which differs in only. Next, move on the step 2. In step 2, we have to make such a group that which differs in only one position. That is, compare each binary number with every term in the adjacent next higher category, and if they differ only by one position, put a check mark in the step 1 column and then copy the term into the next column with the dash mark. In this position particular they differed. This is the step 2. So in this we will take the first group 0. In this which the 0 group which is differ from only one position in the other group. See, it is all contain 0. If you take ones, the only last position here it changes. All other remains same because B3, B2, B1 all are 0. So we can take here group of 0 and 1 possible here. So group of 0 and 1, it is the B3, B2 and B1, and B0 is dash. Why B0 is dash? Because in this B0 it changes 0 to 1. All other 3 term is same 0. Same way we will compare with the next term 0 to 2. So 2 what happens? First is 2 zeros, it is equal to the 0, and third term B1 is 0 and 1 changes and other term remains same. So we will go with 0 2 combination. So in this 0 2, first 2 term is 0 0 only, and B1 is differ and B0 also 0. So we will go with next term 0 and 8 comparison. So in this the first term is differ actually. So if you take as a 0 8, first term it differs and then all 3 are 0. So we are taken as a 0 in one group, so make it right mark, and we are taken 1 also, we are taken 2 also, and we are taken 8 also. So these are the second step we are taken. Not necessary to take 0 and 2 comparison. Always compare with the next adjacent group. Okay, if you compare with 0 2, it is useless. Why? Because it is 2 number of 1 present in 2, 0 0 number of ones. So always differ is more than 1. So not required. So always take such a group that it adjacent to next one. So go with the number of ones group. In number of one group, first take 1. Now how to do this one? In this the B0 is 1. Just check it out. Number of 2, which one B0 is 1? So B0 is 1 in the 2. So it is possible. So go with the 1 and 3 category. So first one is 1 and 3 category, because in 3 the B0 is 1, in 1 also B0 1, both are same. So which one is differs? Actually B1 is 0 here and B1 is 1, only in B1 difference, other all same. So the B3 is 0 in both side, B2 also 0 in both side, but differs in the B1, and B0 also the same, it is 1. So in this 1 and 3, what is the changes? Both are starting is 0 0, in the middle term is changes, so we made dash mark, and last one remains 1 only. So now go with the next 1 with the 6. 1 with the 6, not necessary to compare because it is last term is 1, its last term is 0. So not necessary to compare with others, it won't work. Then we will go with the 1 and 9. Actually 1 and 9 work because both the B0 is 1. So you have to take 1 and 9. So here what is the difference? The first bit is, it is actually varies. Here first bit is 1, but in 1 first bit is 0. So it differs, and all the other two is both are 0 0, and then we have the term is called last bit is 1 only. So like this position we can say that the 1001 of 9 we can represent bar 001. Okay, so this is how we can do the grouping. Now we can move on the next group. 1 is over. Okay, and we are taken 3 and 9 for this row. Whichever grouping done, just put the right marks. Okay, why right mark I will explain you later. Now go with the second term 2. Now in this 2, what we have to do? 0, 0, 1, 0. 1 is present V1. Just check it out. 1 is present in 3 or not. Yeah, 3 also 1 present. So this grouping is possible here. So you have to make grouping similar way. It is number of grouping is 2, 3. So in 2, 3, the grouping is such a way that 2 is 0, 0, 1, 0, 3 is 0, 0, 1, 1. So last bit is varies. So both are 0, 0, 1 is same, last bit is varies. So this is dash. Like that we can do more groups. Then 2, 3 is completed. Now go with the 2 and 6. 2 and 6 both the B1 is remains same. So we will take 2 and 6. In 2 and 6 what we have to do? The changes in the B2 bit. Wherever 1 present, that bit is changes. So we will go with 0 bar and 1 0. We have to take as it is the 2 how present 0 0 1 0. That is we have to make that wherever 6 next bit is 1. That means B2 is 1 here. So we have to make dash that. That means the third bit it is changes. Now we can move on the next bit. It is called as a something like 2 and 9. See 2 and 9 actually the B1 bit is high but 9 B1 bit is not high. So you can compare like that. If it is not high the one were present, so this is not possible. Okay, so 2 and 9 not possible. Now we cannot take once again with 2 and 7 because it is not adjacent side, so leave it 2 position. Now go with the 8 part. In 8 the 1 is present in B3. Now check with B3 1 where it is only in 9. So we can make as a group of 8 and 9 only possible here. So make 8, 9 here. So 8, 9 what is the same? 1, 1 is both are same. Then here also 0 and here also 0. Here also 0, here also 0. Last bit is changes. So it is 1, 0, 0 bar. Okay. Now all the 3 bit we checked 1, 2, 8 and then we checked with 3, 6, 9. 6 is present in 2, 6 group. So all the portion we are done in the second group. So we made as a tick mark. Now go with the second ones and 3 ones comparison. Now in this we have the bit is called 3. So 3 is 0, 1, 1. Any group that having last bit 1, 1, yeah. In the 7 it is last bit is 1, 1. So we will go with the 3 and 7 grouping. So 3 and 7 grouping possible. In this the last bit is 1, 1 same, but the B2 is 1 here once again. So we will make such a way that 0 bar 1, 1. That means the B2 only differs in 3 and 7. All other are same. Okay. Now we will go with the 3 and 14. But 3 and 14 what happens? 3 is B1 B0 once, but 14 it is B1 B0 is different. So it is not possible. Okay. Then we will go with the 6. 6 is present B2 B1. Yeah, B2 B1 present in 7 also. So we will do the grouping of 6 7. In 6 7 the similarity is last bit is 0 in 6, 7 is 1. So it is 0 1 1 is equal and last bit is it differ. Okay. Again you can go with the 6 and 14. Yeah, B2 B1 he is here 1 and in the 14 also it is 1. So we will go with the 6 14 possible. In 6 14 what happens? We will get as a something called as a first bit is differ 14 1 and 6 0. Other all same, that is 1 1 0. This way we made 6 to the these two numbers. Now move on the 9. Now 9 actually contain B3 and B0 is 1. So 7 is not present, B3 and B0 is 1. So it is not possible in the comparison. 9 and 14, again wherever 1 present in 9, that is B3 B0, it's not equal, because in 14 B3 is 1 and B0 is 0, so it is not equal. So not possible of 9 with the any one of 7 and 14. Now 3, 6, 9 is over. 7 and 14 we are used in different parts, so we make it in the tick marks here. Okay. Now we move on the 3 and 4 number of ones grouping. Now 3 number of ones, actually 7 here. So usually 3 number of 1 and 4 number of 1, all possibility is possible. So it is B2, B1, B0, 1 in 7, in 15 also same. So we will move on like this, 7 and 15 grouping. So in this, the first bit is differ and all the other bit is 1. Similar way, we will go with the 14 and 15. The last bit is only differs in this 14 and 15. We have all the 3 is 1, last bit is differ. Like this, we are made as a second step. What is the second step you are done? We are done such a grouping that it only differs in ones. One shortcut method what I am telling you people, if you are making that, only check with adjacent side and only check that particular number is where 1 present, next adjacent whichever that same binary weightage 1 is present, compare with that one only, other leave it. And always remember, if 0 present, it is always possible to compare with the all number of ones in the group. And one more thing, if 3 number of ones, always compare with the 4 number of ones possible. Okay, so zeros whatever present, it's always compare with the number of ones, and 3 number of group always possible to compare with the 4 number of ones. Okay, these are the some tricks in the Quine-McCluskey. In this grouping we can say 15 is possible in 7 and 14, so we can make right mark. In this grouping all are right mark, so step 1 usually we will neglect. Now we are done with step 2, now move on the step 3. In step 3 we will repeat the process whatever we are done in step 2. In this case both dashes must be in the same position with only one other variable allowed to change. The creation of a new table further group the set of minterms. This is the same process repeated. The change is here the dashes should be same position, but another bit may be in 1 changes, either 0 or 1 changes. We will go with the example, we will check how it changes. If you are going for the step 3, you have to create similar table how we are done in step 2. So it is M, B2, B1 and B0 same as previous. Now we have to make such a group that the dash position is same and only 1 changes in these 2 bits. First we can take 0, 1 position. So in this 0, 1, the last bit is B0 same. Now go and check with which one is last bit same. Yeah, in 2, 3 also it is last bit same. So 2, 3 the last bit same, the differs in B1, because in this B1 is 0 and here B1 is 1. So it is differ. In B3 and B2 both are 0. So we can say that it is similar way that if you take the grouping of 0, 1 and 2, 3, the differs is first 2 bit is 0, 0, then it is changes here 1, 0, so dash, and anyway last bit is dash. This way we are made grouping of 0, 1 and 2, 3. Similar way check with 0, 1 others. There is a one more possibility in the 6, 7, the bit B0 is dash. But the thing is here, it is not single changes. Here B2 and B1 both are 1 here. But in the 0, 1, B2 and B1 is 0, 0. So 2 changes in these cases. So 0, 1, 6, 7 is not possible grouping. And other are not in same position of dash. So not necessary to compare with all this stuff. One more position is 8, 9 there. Just check it out. Yeah, 8, 9 grouping is possible here. Because dash in the same position, B3 only it is 1, 0 and B2 is both are 0, 0. So it works. So we will go with 0, 1, 8, 9. So first bit is differs and then both the bit are 0, 0 and B0 is anyway it is dash. So we are done with the 0, 1 grouping. Now go with the second dash. Second dash present in 02. So 02 is second dash. Similar way in 13 also second dash. And last bit B0 is only differ here, and B3, B2 are similar because B3, B2 both are 00. So we can make grouping of 02, 13. So 02, 13, the first two bit are 00, and the changes in the dash in the anyway second bit, and last bit is 01. So last bit it is dash dash. Now we can go with the next one. Next one, there is no dash in the second position B1, so 02 is not possible in any other combination. We will go with the next one, 08. 08 in the first position. So first position, the similar way we have in 19. So 19 we can group it possible because the first position is differ and all the other position B2 and B1 are same. B0 is only one variation. So we can take 0, 8 and 19 position. So the 08, 19, the anyway first 9 is dash, next is 00 and last bit is it is differ. So we are taken 08, 19, so make it grouping. Whichever we are taken, that we have to make tick marks. We are taken 01, 2, 3, so 01 and 2, 3 we are made right mark. And 0189, so 89 also make tick mark. Then 02, we have to make 02 also tick mark. Then 13, so 13 also make tick mark. And then 08, 19, 08 already done, 19 now we are done. Now go with the 08 once again, the first dash, and it is there in 6 and 14. Usually 6 and 14 is not possible because here B2, B1 is number of is 00. Here it is number of is 2 ones. Usually it is not possible. So again 7 and 15 also not possible because last 3 bit is 1 here. Last 3 bit is 0. So go with the 13. The 13 B1 is dash. So nowhere in the B1 dash afterwards. Already the 02 is we are compared. So go with the 19. 19 is last bit dash and it is compared with 08 already, and 19 with 614 we can compare because 614 also first bit is dash. So in this case what happens, the B2 and B1 is 0 here, and but in this in 614 it is 1 1. So two difference not possible. Similar way we can go 715 also, two number of ones, so it is also not possible. In the 2, 6 we have B2 is a dash and upper position not necessary, we will go with down position. 3 7 also dash. Here 2 6 and 3 7, the first position both are 0, second position both are dash, third position both are 1, and fourth position only change. So we can do the grouping is possible here. So we can do the one more grouping, that is similar way of previous, that is 2 6 and 3 7. The first bit is 0, then it is dash, then it is 1, the last bit is differ, so it is dash. Now in 06 B2 is dash, but nowhere in the B2 is dash here. 3 7 we are completed, and so we will go to next one, 8 9. 8 9 is last bit dash, so it is similar to 6 7 last bit dash. The issue is here the B2 and B1 actually 0, but here in 6 7 B2 B1 is 1 1. So two difference. So 8 9 6 7 is not possible. So nowhere in the B0 dash there. So we will move on the 3 7. 3 7 dash will go with the downside. Nowhere in the B2 is dash. So 3 7 not possible to other grouping. Now go with the 6 7. 6 7 is last bit is dash, but nowhere in the downside last bit is 0 dash. So we will leave it the 6 7. Now go with the 6 14, the first bit dash. So first bit dash here 6 14 and 7 15 also possible. In 6 14 7 15, first bit B3 is both are dash, and then we have the B0 position is only changes. So we will make the grouping of these two, that is named as 6 14 and 7 15. So here in this case the first bar is dash, then 1 1, then it is 0 1 is we can represent as dash. This is how we can form the step 3. Now whichever we are included in step 3, that we have to make tick marks in the step 2. So 0 1 we have to make tick mark. So 0 1 done, then 2 3 we have to make tick mark, 2 3 done, 0 1 tick mark done, 8 9 tick mark done. Similar way we have to make 0 2 tick mark done, 1 3 tick mark done, then 0 8 tick mark done, then 1 9 tick mark done. Okay, then we will go with 2 6 and 3 7. So 2 6 also you have to make tick mark, then you have to make a tick mark in the 3 7. Okay, then 6 14 and 7 15 also tick mark. Okay, in this the 6 7 we are not included, this group we are not included anywhere, all the other group we are included in the step 3. Here one more thing we have to remember in the step 3, there is a duplication possible that we have to remove. See here, the 0 1 2 3 is exactly equal to 0 2 1 3, because in this all form it is the number of content 0 2 1 3, it's all are there in the first group, and it is represent both where it is 0 0 dash dash, here also 0 0 dash dash, both are same, so we can ignore these portions. Similar way, where we have one more the term 0 1 8 9, it is similar to 0 8 1 9, because both are the first B3 is dash, then 0 0, then dash, so we can leave this portion also. So from this any other group is not same, because 0 1 8 9 not equal to 2 3 6 7 different minterms, again 6 14 7 15 different minterms, so usually these are not a same group or duplicate one. So in the step 3 we got 4 groups. The group is 0 1 2 3 is one group, 0 1 8 9 is one group, 2 6 3 7 is one group, 6 14 7 15 is one group. In step 4, we are doing that any non-checked minterm group is there, that we have to check, and whatever in the step 3 groups we are got, all we are considered as a prime implicant, and from that we are making as a one more table. From that table we will check which are the prime implicant we will take as a grouping part. If you take group 1 table here, in this group 1 table, all term we are used to take table 2, so all are tick mark done. So we will go to group 2. In group 2 also we are considered every groups. Here the one group actually we are not done tick mark, that is 6 7, but check in the your table 3, it is sure that 6 7 already present in this portion, so already present, so we can make tick mark here. So in this group we can say that in the step 2 also all the group are tick mark, so 14 15 also here present. Okay, so how to make tick mark? Any particular term is not grouped, but here first table to second table every term is grouped, second to third table also every term is grouped, so everything is checked, so no unchecked. So we are moving to the step 4 such a way that only we are taking the part of the position where the step 3 part is there. Now we are moving to the step 4 position. In the step 4 position is such a way that all groups are checked in step 1, step 2, so we are not considering any group from there. And in the step 3 whatever the term we have to take all term as it is. So we can say that in the our term here is, first we will take as a m as it is. Okay, first we will take m here minterm, so only it present in the whatever in the step 3. So step 3 we have 0 1 2 3, and then we have 0 1 8 9, and then we have 2 6 3 7, and then we have 6 14 7 15. So actually the step 4 says all non-checked minterm in each steps, but step 1 step 2 all are checked, so we will not go with that. And step 3 whatever the term taken everything we will take here. So here we have to make such a column that according to the given problem. Here given problem, that is there 0. So first column it is 0. Next is given 1. So 1. Again 2, 3. Then given is 6. Then given is 7. Given is 8. And given is 9. And then 14. Then 15. So in this 0, 1, 2, 3, wherever 0 present in this column, so 0 present here, 1 present here, 2 present here, 3 present here. 0, 1, 8, 9 means 0 present, 1 present, and then 8 present and 9 present. Next 2, 3, 6, 7 means in the 2 column, and then 6 column, then 3 column and 7 column. Again 6, 14, 7, 15. So 6 and this one is 14. Then we have 7, then we have 15. This is how we can mark the stuff according to our grouping with the columns. Once we are done, first any column having the single term, suppose in 0 having 2 term, so we cannot take that. 1 having 2 term, 2 having 2 term, 3 having 2 term, not possible. 6 and 7 having 2 term, but 8, 9 having single term. So mark this one, 8 and 9. Again we have the single term is 14 and 15. We have made circle such a way that which is only one column it is present. So in this 0, 1, 8, 9, we can take that 8, 9 is not present in any other part. So we can take this portion. Again 6, 14 and 7, 15 we can take. These two we are calling as a essential prime implicant. That means it is not present anywhere. So we can make one that we can take 0, 1, 8, 9. This is one essential prime implicant. Another one is 6, 14 and 7, 15. Now we are taken only the two group whatever we are taken, these are called essential prime implicant, but the simplification only is not a essential prime implicant. It also contains the possibility of RPI and SPI possible. That means redundant prime implicant and selective prime implicant. But in this case, how to check only essential is enough or we require other group also. So whichever group we are taken, we will cross verify with that. If all the column is present in this group, then only essential prime implicant is enough. If not all the group is formed, then we have to go with extra grouping. So first take 0, 1, 8, 9. So in this 0 is present, 1 is present, 8 is present and 9 is present. Now take with 6, 14, 7, 15. So in this 6 is present, 14 is present, 15 is present, 7 is present. Now the stuff is in this column the 2 portion is not finished, that is 2 and 3. So we have to take one more equation which can present 2, 3. But the here interesting thing is 2, 3 is present in both the group. Either 0, 1, 2, 3 also 2, 3 present. 2, 3, 6, 7 also 2, 3 present. So it is called as a selective prime implicant. So you can either take 0, 1, 2, 3 to the group, or you can go with the 2, 6, 3, 7 also another group. In that we can make as a something like that 0, 1, 8, 9 anyway essential prime implicant. That means this is required only 6, 14, 7, 15, and either I can take 0, 1, 2, 3 or we can take 2, 6, 3, 7, because when you check with the column of these two essential prime implicant, 2 and 3 is not actually taken column. So we have to take such a equation that cover 2 and 3, but here both the group can cover, so we cannot take both the group, any one group we can take. Okay. Now we will move on the last step, converting into the equation. How to convert equation? First we have 0, 1, 8, 9. See in the step 3, 0, 1, 8, 9 we are made B3 is dash 0, 0 again dash. So it is whichever dash contain that we cannot take and whichever 0 contain that we can take. So in this we can take as a B2 dash and B1 dash. Either we can call ABCD also. So it is nothing but if you call this one as a and this one as a B, this one as a C, D, then we can call this one something like that B bar, C bar. Okay, similar way, if you take 6, 14, 7, 15, so this group here, the B3 and B0 is dash, so not required. B2 and B1 is directly, no complemented. So we can take B2, B1, or if you take in form of ABCD, so it is BC. And one more grouping we are taking something called 0, 1, 2, 3. So 0, 1, 2, 3 is this group. Here the B3, B2 is 0, 0 and B1, B0 is dash. Dash means ignore it and B3, B2 is present. So we can make that B3 bar and B2 bar. So if you want to present in ABCD, so B3 bar is nothing but A bar and B2 bar is nothing but B bar. So from this equation we will got as a something like that. It is B bar C bar plus BC plus A bar B bar. This is the one equation. Also we can do the another equation possible. So here instead of 0, 1, 2, 3 we are taken 2, 6, 3, 7. So it is 0, 1, 8, 9 similar way previous, that is B bar C bar similar way, and 6, 14, 7, 15 it is BC from previous only. Now check with 2, 6, 3, 7 what is that. 2, 6, 3, 7 we can call as a 0 bar 1 bar. So bar portion we can leave it 0, 1. So 0 is B3. So make B3 bar and 1 is nothing but B1. So B3 B1. Also we can represent B3 bar B1 as A bar C. So one more equation possible we can call R, that is B bar and C bar remains same plus BC remains same plus instead of A bar B bar we can write A bar C. So this A bar C and A bar B bar are selective prime implicant. Either you can select this or this, and B bar, C bar and BC are essential prime implicant, both the group we have. So this way we can simplify the any Boolean equation using Quine-McCluskey method and we can find the final equation.